Hello all. So in the last session we have started unit 5. Unit 5 is all about unsupervised machine learning algorithms. We have seen there are two main categories of unsupervised super machine learning algorithms. One is clustering, second one is association. We have started with clustering. We have also seen one type of clustering algorithm, or the most basic, most important clustering algorithm, which is k-means. And we've also seen how clustering is used for image segmentation, how clustering is used for data pre-processing, and how clustering used for semi-supervised learning. Okay, so today in this session I would like to talk about another most important clustering algorithm, which is called as DB-scan. Okay, so DB-scan stands for density based spatial clustering of applications with noise. So whenever we talk about clustering, okay, so we have seen clustering is all about grouping the data into different segments. Okay, so clustering analysis, or simply clustering, is basically unsupervised learning method that actually divides the entire data into some specific number of groups or batches, which we call it as clusters, right? So we have seen k-means clustering, which is actually distance based, or distance between the points based clustering, right? Similar to that, we have this another clustering which is called DB scan, which actually measures the distance between the nearest points. Okay, please understand the difference between k-means and DB scan. K means distance between the points, whereas when I talk about DB scan, distance between the nearest points. Okay, so fundamentally all these clustering methods use the same approach, that is, we first calculate similarities and then we use it to cluster the data points into given batches. Okay, so but when we talk about DB scan, we will focus on, how do we calculate the nearest data points. Okay, so when I talk about DB scan here, basically in data science or machine learning, the ability to cover the hidden patterns, uncover the hidden patterns and group similar data is all about your clustering, which we have been seeing. Okay, so the primary goal of clustering is to simplify the large data set into some groups, identify the natural groupings within the data, and reveal the hidden patterns or the structures. Okay, so DB scan is one such popular clustering algorithm which is used for grouping the data based on the density, that is identifying the nearest points based on the density. Okay, so unlike k-means, DB scan doesn't require specific number of clusters, because when we talk about k-means, we have to give the specific number of clusters, that is step 1 would be identify the value of k when I talk about k-means, right? But here that is not the case. DB scan will actually doesn't require that in advance, but DB scan will focus mainly on the density. Okay, making it useful for variety of applications. Okay, so while there are numerous clustering algorithms that we have just listed. Okay, so we have studied about k-means, but we also have hierarchical clustering, DB scan, GMM, Gaussian mixture models, which we are going to see in the next session. Okay, so out of all this, DB scan offers some unique advantages. Okay, as it is a density based method, there are some advantages when we talk about DB scan algorithm. The first one is its flexibility in cluster shape. Okay, so we don't have fixed number of clusters, we have flexibility in cluster shape that we define, and no predefined number of clusters. Along with the shape, number of clusters are also not predefined. And then DB scan handles the noise because we are arranging the data into clusters based on the density, and it is completely density based insight. Okay, these are some advantages when I talk about DB scan algorithm. Okay, there are three important points that you have to understand when we talk about this DB scan algorithm. First one is, DB scan is all about core points. Okay, core points are nothing but the points that have at least minimum number of other points. Okay, when I talk about other points within a specified distance, if you have minimum number of points, we call that as core points. We represent them as epsilon. Okay, now when I talk about second point, which is border points. Okay, these are the points that are with the epsilon distance, with the specified distance of the core point, but do not have minimum point neighbors themselves. Okay, are you understanding? Don't get confused. Core points are nothing but the least minimum number of other points within the specified distance, whereas border points are the points that are within the epsilon distance of a core point but do not have any minimum point neighbors. Okay, and there are the third one is noise points. Okay, these are the points that are neither core nor border. They are not close enough to any cluster that has to be included. Let's clearly see this: core points, border points, noise points. Okay, and you look at the picture. Okay, the noise points are not within the cluster. Okay, core points are what? Core points are nothing but the points that are minimum number of other points within a specified distance. If suppose this is the distance, the minimum number of points within this distance are nothing but the close core points. When I talk about the border points, within the epsilon distance of the core point, but do not have, there is no minimum quantity, but within that epsilon border, whatever we have, we call them as the border points. Okay, the yellow one are the border points, these are the core points, and the one neither border nor core are nothing but your noise. Okay, so this particular diagram will actually illustrate these three concepts of core points, border points, and noise points. So core points form the heart of the clusters, border points are the edges, okay, and noise are the isolated ones or like outliers. Okay, so these are the three components that we have to understand, or three important concepts that we have to understand when we talk about DB scan algorithm. Okay, so there are two points as you have seen. Forming these core points, border points, and noise point, we require two important things. One is epsilon and the second one is min points. Okay, so epsilon is nothing but the maximum distance between 2 points for them to be considered as neighbors within that particular given area for that cluster, and minimum points are nothing but the points required to form a dense region. When you adjust these two parameters, what are the parameters? Epsilon and minimum points, you can control how the algorithm actually defines clusters, adapting it to find different types of data set. The entire data would be divided into different number of clusters based on how we define epsilon and how we define min points. Okay, these are the adjustable parameters that actually defines how your DB scan algorithm is going to work. Okay, now let's talk about how does the algorithm works. Okay, so when I talk about DB scan algorithm, it operates by examining the neighborhood of each point, whether to include that in the core point or the border point. Okay, so the algorithm will have a step by step process which we will see in the next preceding slide, which will actually helps us in identifying the clusters based on the density. When I talk about density, okay, density is all about how we are arranging the minimum points and how we are arranging the epsilon within that given cluster. Depending on epsilon value and minimum points, we have the density based, we have the density being defined, hence we call it as density based algorithm. Okay, so there are two important things that you have to understand. First is parameter selection. As we have already discussed, how do we choose epsilon and how do we choose minimum points is one important thing. Next, that selecting the starting point. From where do we start the cluster with? Okay, so the algorithm starts with an arbitrary unvisited point in the data set, and based on that we will start working on with the algorithm. Okay, so once you are done with parameter selection and selecting the starting point, we will actually examine the neighborhood where we try to retrieve all the points within the epsilon distance of the starting point. So here I have already defined epsilon, I have already defined minimum points, I have already defined a starting point. Based on epsilon and the starting point, we will try to examine the neighborhoods. Okay, if the number of neighboring points is less than minimum points, the point is labeled as noise, otherwise it will be included into the cluster, or we call it as core point when a new cluster is formed. Okay, once we are done with examining the neighborhood, we will try to expand the cluster where all the neighbors of the core points are added into the clusters. Okay, so when you are doing this particular point, you have to make sure that if it's a core point, its neighbor are added to the cluster recursively. If it is not a core point, you have to make sure that it's marked as a border point, either core point or border point if the condition is satisfied. If not both, the third option is it comes under your other, that is your outlier or noise point. Okay, so we will repeat the process, same thing. Okay, what do we repeat? First, choose the parameters, select the starting point, examine the neighborhoods, expand the cluster. Okay, based on this we will try to repeat this process again and again. Okay, until unvisited point in the data set reaches. So step 3 and 4 would be repeated until all the points are visited, and all the points would be either put as core point or border point, or if they don't belong to any of the category, we consider them as noise point. So once we are done with the entire process where we visit all the data points, we will finalize the cluster, all the points will be processed and the algorithm will identify all the clusters, and then finally define the clustering. Okay, so any points that does not belong to any classifier, any cluster will remain classified as noise. Okay, so this way we can say DB scan algorithm can also be used specifically for identifying the outliers in the data set. Okay. So, this 6-step process will actually allow DB scan to form clusters of arbitrary shape and identify outliers effectively. Okay. So, the algorithm's ability to find clusters without specifying the number of clusters beforehand is one of its key strengths, because when we talk about k-means clustering, the first clustering algorithm that we have seen, the first step itself we have to specify the value of k, how many clusters you want to form. Okay. But here we are not forming anything, based on the density of the data, based on core points and the border points, we are actually dividing the clusters. Okay. So, that is without defining value of k, we are forming the clusters, which is one of the advantages of DB scan. Okay. Now, let us basically understand DB scan versus k-mean. When I talk about cluster shape, can identify clusters of arbitrary shapes. Here assumes clusters are convex and roughly spherical. Number of clusters does not, we need not prefer it specified before, whereas for k-means you have to specify k in advance, identifies outliers as Noid points, forces every point into cluster, potentially distorting cluster shapes, sensitive to epsilon and mini points parameters that we are supposed to adjust. Here only the value of k has to be adjusted. Can find clusters of varying densities, tends to find clusters of similar spatial extent and density. Okay. So, these are some basic differences between the first clustering algorithm k-means and DB scan. Okay. So, when I talk about DB scan, first advantage is we need not specify number of clusters, works well with non-globular clusters, that is arbitrary shaped clusters, handles noise and outliers effectively. When I talk about disadvantages, parameter tuning, okay, optimal EPS and minimum samples can be challenging, not efficient for very large data sets with high dimensionality, because each and every point has to be considered for putting it into core point or data point, and uneven densities. Okay. So, struggles when clusters have varying densities. Okay. So, when we talk about identify clusters on a map, satellite images. Okay. So, identifying satellite images from the space. Okay. So, for that geospatial data we use DB scan. For segmenting objects in images, identifying outliers in data sets, anomaly detection, these are various applications that we have when we talk about DB scan algorithm. Okay. So, this is all about the second type of algorithm, clustering, unsupervised clustering algorithm, which is DB scan. So, so far we have discussed two important clustering unsupervised learning algorithms. One is k-means, second one is DB scan. Thank you.